Okay, now let's look at some examples of how trig ratios are in quadrants 1 to 4. Perfect example is like this. The scenario I've given you, we have a theta standard position angle that lies in the following quadrants, and the condition is given to you. We want to know which quadrant it is. All right, cosine, the first example right here. Sine is negative, cosine is positive. So quickly, let's go through a diagram right here, and we're gonna shade the area that is positive. So sine is positive. What are the areas that the sine is positive? Well, sine is positive in quadrant 1 and quadrant 2. We know that, all right? And where cosine is negative, well, cosine is negative in quadrant 2 and quadrant 3. And look at the common region for both that is shaded. Which quadrant is it? Quadrant 2. That's where the angle is. So if I have to quickly draw the standard position angle, chances are that's theta. Okay, so we're going to do the same thing for question B, part B. Same idea again. Quick sketch, very easy. All right, we go through it. Let's start with the positive one. I always like to go with the positive one. Cosine is positive, that's greater than 0, right? Tangent negative. Let's start with the cosine. What are the quadrants where cosine is positive? Where cosine is positive, that's your x value in quadrant 1 and quadrant 4. Great. Which quadrant tangent is negative? Well, tangent is negative in quadrant 2, right here, and quadrant 4. Excellent. So what is the common quadrant for both? Quadrant 4. That means if I draw this angle right here, a standard position angle theta, that theta lands in quadrant 4. Okay, simple as that. That's how you navigate through situation like this, where you can figure out where theta is located in what quadrant. Okay, let's look at another example. In this case, we have this angle theta, and theta, when you take the sine of that, it gives you a ratio of approximately 0.65, and that's to the nearest degree. The question is, we need to find all values of that angle. Okay, so here is the part where you have to be going through the CAST acronym. Okay, first, the very simple thing, the very first thing that you do is that you just write sine of theta equal to 0.65, and the very first thing that you do is that you use your calculator to find theta, the very first value of theta that you can come up with. And it's simple as that. So you go to your calculator, scientific calculator, make sure your calculator is in degree mode, and then you just punch in 0.65, and then trigonometry, second function, and I want the sine. Here we go. If I can get that, here we go. Sine of that. So I get approximately 40.54. So approximately theta is 41 degrees. That's what I would get. And I quickly sketch the standard position angle in theta in quadrant 1, which is right here. That's 41 degrees based on the first value that I get. Now, are we done? No, because it tells you that this theta, we have to come up with all values of theta that will give you the same ratio. This is the part where you have to use the CAST. Sine of theta is positive in what quadrants? In quadrant 1 and quadrant 2. That means you must have another angle in quadrant 2. So here is another standard position angle, but the way you do this is that you draw a terminal arm, you're going to use the original, the first angle theta 1 that you found as a reference angle, which is right here. That has to give you the same reference angle if it's going to give you the same ratio. And then the new standard position angle in quadrant 2 is 180 degrees minus 41 degrees, and in this case will end up being approximately 139 degrees. So make a note here, we have a sine of theta positive in quadrant 1 and 2. That means you have the first angle in quadrant 1. We need to find another angle in quadrant 2. So theta 2 is 180 degrees minus 41 degrees. And that's again approximation. And that's 139 degrees. And this is why you need the cast, okay? So every angle that you have, depending on the ratio of that angle, you will have the same. So two different angles, two different quadrants, same ratio. And that's one of the perfect example of that, okay? So let's look at another example. And we're going to do it quickly enough. So tan of theta equal to -1. We want to find all values of theta between 0 and 360 degrees that will give you the same ratio, -1. So first thing you do, you use your calculator. So tan of theta equal to -1. So theta equals to tan inverse of -1. And you go to your calculator, and this is the part that is very crucial. So make sure that punch in -1, that's negative, and I'm going to go to trigonometry, second function, tangent, and I get minus 45 degrees. Okay, that's minus 45 degrees. Now, where is minus 45 degrees? Let's quickly sketch that. Well, minus 45 degrees is a negative. That means the direction is now clockwise, is actually here. That's minus 45 degrees, right here, minus 45, because you're going the other way. But we can't have a negative angle because of the domain that is given to us is actually between 0 and 360 degrees. So what is the first angle in the fourth quadrant? Well, our angle is at 360 degrees minus 45 degrees, which is 315 degrees. So this theta is minus 45 degrees. It's a coterminal angle to 315 degrees. So that's our first angle. I mean, it's not necessarily first or second, but that's one of them. All right, next. In what quadrant tangent, so tangent is, that's a negative value, right? So in what quadrant tangent is negative? Well, quadrant 4 and quadrant 2. So now you use this reference angle. So this is the minus 45 degrees. So the reference angle to minus 45 degrees is, I have to kind of try to make it as, here you go, straight up. And that is the standard position angle with the second one, theta 2, based on this angle that is a reference angle 45 degrees. You always use the reference angle that you get to find the second angle in whatever quadrant it is. What is theta 2? Well, theta 2 is 180 degrees minus 45 degrees, which is 135 degrees. So based on the 35 degrees, you notice that the reference angle is 45 degrees. And then in second quadrant, in quadrant 2, you have 180 minus 45 degrees, and now you get 135 degrees. And when you punch in the calculator, what is the tangent of 135 degrees, then you will get -1. And when you do the same thing for 315 degrees, you get -1. So let's check that actually, instead of just talking about it, let's check. We're going to use a calculator. Okay, let's go through the first one. Here we go. Let's do the 315 15 degrees, and then we're going to take the tangent of that. Let's see if we get -1. Yes, we do, right here, -1. So that's the first one we checked. Let's do it again for 135 degrees, 135 degrees. I'm going to take the tangent of that, -1 again. That's check as well. Here you go. That's how you check your answers, but notice that the same ratio, tan theta of theta equals to -1. This is the ratio that we have. This ratio, -1, has to be using two different angles, theta 1 and theta 2. One is 315 degrees, the other one is 135 degrees. All right, that's it.